right, I think we it's time, is it, or are we a little bit early maybe? 1 minute more. I think at least one of you guys were not here the last time, if I'm not mistaken. What we did was to do an introduction to the basics in casing design, which would be material science. We talked about the introduction of the whole casing design part of the course. You see those 6 points here. We covered point 1 the last time, and we started on the point number 2, introduction to weld construction, and we'll continue on it today. We talked about why and how we do casing design, basic material science, properties of iron, how carbon is affecting iron, how alloys are made, and what the different components may do to iron. Testing to find yield and how that works as a function of a curve. The yield strength of steel is very important to us, and that it's heterogeneous, meaning that it performs and behaves the same in compression as in tension. We talked about steel qualities, how they are made, and how the pipe manufacturing process is. Pure melt is coming in from the top of this flow chart. You make a billet, which is just a solid rod, and then you pierce it until a piece of pipes for the seamless, whereas it's a sheet that is rolled into a tube and then welded for the other qualities. And we talked about the other process, like rolling and then quenching the material, what it means, and how that affects steel all the way down to the atomic level. This phase diagram for steel is showing how steel behaves as a function of heating it or quenching it sudden. And the composition of it. Typically, this example is steel quality, carbon steel, mild steel quality 4130, commonly used in a lot of components in the industry and installed in wells. This example, we discussed it in detail the last time, how it works. And that steel is a material based on crystals that forms from liquid to solid, and the mechanisms as you heat it again and so on, and that working the steel either with the heat, not in we'll call it to full melt of the whole thing, or recrystallization. It means that, for example, welding, you have growth of these grains, and the material as per se becomes weaker. The same for rolling. If I can see that example again for those who are not here, I can't find that slide. That's okay. The grains, they get elongated. Here it is. So you roll it, and then call it the randomly shaped small grains, they now are oriented, which again reduces the strength of steel. All part of the process here. Industry is very aware of what they are doing, and what they do is to recrystallize this steel after working it to regain the strength, original strength of it. We talked about external forces, how they act on steel. Inside the steel, it's not a vector anymore. It's what is called a tensor with 9 components. What I may have forgotten the last time um, is 2 notes to make about the red section of the von Mises equation. We do use the Lamé principal stresses for tubulars, which makes the red part of the equation become 0. But in cases where we are actually rotating, let's say that you rotate a liner and you want to know the stress capacity, then the shear stresses are no longer 0. But that's not normally the case. Our cases, and that's part of what we're going to study today, we're looking at different scenarios, and we analyze the life of the well as part of our design strategy. It means that we investigate full production, shut in, if there's a gas kick, and any of those things that may occur during the lifetime of the well, we investigate it. And these scenarios, we call them load cases. And there's a set of load cases proposed in these presentations and the compendium following it. And also you'll find a small selection in the NORSOC D10 of proposed load cases to analyze. And in principle, just to say that, we do predict, it's a prediction for the whole lifetime of a well. So going through this set of load cases, then we kind of say that, this is what the well can be seeing during its lifetime, and from that we say yes, the pipe is acceptable for use through the life cycle of the well, or no, we have to go to something either thicker or stronger, or both. So rotation, that is normally not part of any of those load cases. Why? Because basically there are operational limitations, such as, for example, for liner, it would be the torque of the makeup torque of the connections. You cannot pass them. You exceed that torque, and you over torque the connection, which makes it no longer in spec, to put it very objective. To say it in another way, it may start leaking, no longer gas tight, so on and so forth. And once you park the liner, you're no longer rotating. You de-stress it so that it has the normal capacity again. But for drill pipe, it's a different story, and altogether different load cases, obviously. And that being said, the only things that we normally do as drilling engineers for drill pipe would be to do torque and drag. Yeah. And the torque that you sometimes have on drill pipe may be quite impressive, extreme amounts. Not necessarily what you make up the torque, the pipe to, but as you are rotating and you have shocks and vibrations, to break it out, sometimes you have to go to extreme torque to release the drill pipe joints from each other. Yeah, that's a good story, I guess. Just putting the equation in perspective for you guys. We talked about it the last time, what it means and so on. Other than that, we just established that everybody in the course know the very basic of the naming convention, both of casings and wellhead Christmas tree parts, and that the subsea Christmas tree has a lot of similarities to the regular dry wellheads onshore, or for that matter, dry Christmas tree wellheads offshore. Yeah. Uh, Obviously, layouts and the functionality and operation would be different between the two of them from the nature of access and ability to operate. We talked about how things work for land-based wells, and I promised you guys that there is a chance that we can look at how uh, the construction starts and how it progresses, how you assemble casings and Christmas trees and so on for subsea. Um, that being said, I think that I need to ask you guys: Have you seen how this works for subsea wellheads and casing hangers, Christmas trees? Have you seen how they assemble? Yeah, I have a video here so that we can actually look at the video. No, that's not it. That's not what I was aiming for. Let me see. It was supposedly here. Okay. I need to start it again. That's not what I wanted though, but okay. So we are going to have a quick look here at this system.
The Host 1000 system, or hinge over subsea template system, is being used in the development of the Terra Nova field. The host systems are contained in a series of 4 glory holes that were excavated in 1999. These glory holes enable the subsea equipment to be placed below the seabed for protection from iceberg scouring. Once the drilling vessel is in position, the hole for the 36-inch foundation casing is drilled. During this operation, a Merkur cuttings disposal system is utilized to transport cuttings away from the drilled hole. This system is not shown in this presentation.
Cheat and do this.
The 36-inch pipe is made up at the surface.
Yeah, what we just saw in the beginning here, this is a presentation from what FMC did for Equinor in Canada, East Coast Canada. I think it must be 20 years ago or something like that, maybe even more. Uh, the very first part that we probably didn't notice so well, it's called a glory hole. On the east side of Canada, there are icebergs coming in, and the glory hole is just a yeah, you excavate a little bit out of the seafloor, so that if an iceberg comes, then it will go out over it. And what you do, you investigate all the scouring nearby. How deep are the trenches from the icebergs, and then you dig a little bit deeper so that your Christmas tree comes below this. It's called the excavation. The depth of what you're doing is just what they call a glory hole.
Pipe is run into the pre-drilled hole. Once the host is at the prescribed elevation, the hogs are lowered. This operation on the hogs and allowing them to be lowered to the horizontal position. The ROV will later provide guidance for the well drilling operations and the guidance equipment. The pig loop porch or PLP structure PLP is then lowered to the horizontal position by the downline. The ROV releases the shackle on the PLP, and the installation sling is retrieved to the surface. The 36-inch running tool. The 36-inch running tool is retrieved to the surface by once the PLP is installed, the hose must be checked for level before available simply drilling guide bases are installed. An inclinometer is lowered on a guide rail and landed on the host at an approved level to measure the exact level of the assembly. The inclinometer will be ran at any point in the host installation. It is a means of determining the level of all items. If the host requires leveling, the ROV moves into position and uses the torque tool to rotate the leveling mechanism. The inclinometer is then retrieved to the surface. The individual well slabs are drawn by installing a bump guide into the hinge on the bow base and then drilling a half of 7-inch casing through the head. Once casing depth is fixed, the drill bit is removed and casing is laid. The permanent guide base, or PGB, and 30-inch wellhead assembly are the 30-inch the 18 and 3/4-inch UWD 15 high pressure wellhead housing is mounted onto the 20
This is called a surface casing. So they drilled first a conductor with this PGB, and then they drilled for the surface casing, which is now coming in, and it locks into the PGB so that it takes all the forces that will be from thermal expansion in the well. We will talk more about that later on. The conductor is cemented and is holding the whole well in place. We'll see more later.
to the sea floor by an 18 and 3/4-inch cam actuated running tool that is attached to the drill pipe. The casing is guided into the 30-inch casing, and the wellhead assembly is landed in the 30-inch wellhead. Further detail about the UWD 15 wellhead configurations can be viewed in the drawing section of this presentation. Once the mating operations are completed, the wellhead assembly the host system provides significant economic and operational advantages to the operator. Upon completion of drilling operations, the manifold assembly is prepared for installation. The host production and gas lift manifold is made up of a 10-inch production and 6-inch gas lift, which contains 6 by 2-inch branch lines rated at 4,200 psi working pressure.
Yeah, a lot of names that FMC use, and I'd say that the systems are very similar across any supplier. What we see here, this would be typically the inlet for the production line, and she talked about in the back here is a so-called pig loop. It means that it's just like a U, so that you can produce out here, and then there is a connection like this for every single Christmas tree. If you guys would like to see more of this and a little bit more detailed how the wellheads are locking in and so on, we can do that. Then you will also see how these connections are made. Now, in the back here, as we talked about in the previous lecture, the pig loop may be replaced with one of these loops, so that you actually can have a fifth well instead. That the drawback with it typically would be that you no longer can do pigging as per se, because the pig loop is just meant for you to pump one of the pigs through here and out there, so you can retrieve it. You circulate it all the way through your whole system, whereas with the fifth well, that's no longer possible. But also, as you guys can see, all wells, they are producing into the same manifold, meaning that they will all have to be at the same pressure level. If wells are at very different delivery rates, pressure wise, and so on, it means that one well may start to produce into another, right? So that's something to think about. And this is a problem also for excuse me, any other onshore or offshore system. You always have a gathering manifold, and you need to consider how to run that manifold optimally. So you have to choke back a lot of the strong producers, and you have to maybe open up the slower ones, or to close in the slower ones to let them build pressure, and then so on and so forth. It's production optimization, not something that we are very concerned about in drilling, but it's going to be our problem in so much that we have to deliver the, call it, the well infrastructure required to meet this. Either it's smart completion to control the different zones, or if it's a remote choke operations, anything that has to do with the well infrastructure. So what you guys think? Should we run a little bit more visual? This first part is very, very basic. The second one, it goes more into details, showing you the locking mechanisms of the casing hangers and the different subsea tools, how they operate and so on. It's definitely up to you guys what you want to see. We could jump over to the presentation. So a hand in the air for those who want to continue.
Are these videos available online?
No. All right. Okay. So then there was 1, 4, and the rest 2, 2, 4, 3, 4. Suddenly, okay, I get it. We go.
Is lowered into position and landed. Once landed, the manifold assembly is inspected. The ROV releases the installation slings, and they are pulled to the surface. In preparation for the installation of the pig loop module, the pig loop valve starts. The pig loop module is made up at the surface and run on drill pipe and installation slings. The pig loop allows for round-trip pigging of the manifold assembly and flow lines to maintain an unrestricted flow path. This flexible, self-contained unit can be retrieved and placed on another manifold or model required. Once landed, the pig loop installation slings are unlatched by the ROV and the tools and routing tool are retrieved. The pig loop is hydraulically moved into position either by the ROV or downward. The ROV applies hydraulic pressure via the ROV panel on the pig loop to operate the swing.
Yeah, I'd like to bring extra attention to this last part where the connector mates up, right? That's what happens also for Christmas trees, which should tell you that the height of the wellhead and its angle is extremely important. If you have a misalignment out of the tolerance, you will not get this connection good, which makes the well impossible to produce. Basically, because the Christmas tree doesn't mate up to its flow manifold. Yeah. So that's why later on you'll hear that the inclination limitation for the conductor is 1 degree. Yeah. And putting up what we talked about the last time, there are a lot of boulders in the both the conductor section and the surface casing. So it can be difficult sometimes to achieve, and you have to measure over and over again to know that yes, it's correct.
Hydraulically locked to the manifold hubs. The Terranova project features 5 by 2 inch, 6,650 PSI. One further operations internal to the well are performed. The flow lines are connected to the host manifold via routing flow line connection system.
Yeah. So the center one is the umbilical, whereas the two ones on the sides would be flow lines. Yeah.
The umbilical termination head assembly is run. The ROV installs hydraulic and electrical jumpers on the host manifold. This provides hydraulic and electrical.
The systems may be a little bit
As the
different.
structure is lowered over the guidepost on the template structure,
And there's a roof for fishing equipment. If a trawler fishing trawler comes, and typically there's a lot of fishing gear getting stuck in and around oil installations because well, typically there's a lot of fish in the area. You know the Tampen and Houghton areas. They are both fishing grounds, and also the fishermen, they get their equipment refunded if they lose it. Yeah. Here comes the more detailed part. UDV 15 is the naming of the wellhead system. The installation and the sequence of it is coming up.
is an 18 3/4 inch, 15 bar. The drill pipe and drill bit are lowered into the house and
Yeah, what she's talking about is an underground vacuum. It means that cuttings, if it's sensitive, for example, here it's a glory hole, you don't want all the cuttings for the conductor and the surface casing to be in and around the area. So basically what you have is a huge pump and a hose so that the pump sucks all the cuttings coming out of what is going to be the well, the open hole, and delivers it somewhere at the end of where you put this piping system. I think we're going to skip this a little bit fast because it's a little bit repetition of the previous part.
Upon completion of the 36 inch,
Yeah.
the 30-inch casing is in place by pumping down the
Yeah, so I think we just skip this very quickly. It's just a repetition of this part. We see more of the tools, how they work. It's typically rotation and weight in combination sometimes. That being said, a lot of these things are actually pre-installed. We never let rigs do any of this work. It will be typically only the conductors. Lines are installed. And also what is different here is basically all these guideposts. There will be just a few of them installed, and you may say that there are long guideposts for operations, but when you are producing, then you have short ones typically, only just covering the Christmas tree. Whereas if you are in completion, for example, you need the long ones to accommodate also the BOP. And for the water depths that we have mainly here in Norway, we run guide wires. So there are tuggers with wires on them going into the sea, hooking up to the guideposts. So you have like guiding of the BOP or the Christmas tree, whatever you are running and operating, all the way down to landing it off. And here we just cemented the
18 and 3/4 inch wellhead running
surface casing.
by rotating the drill pipe to the right.
Yeah, the blue one is the bore protector.
Provides a means for well control during drilling operation. The next operation is to test the integrity of the BOP stack and the VX seal. With the bore protector installed, the 18 and 3/4 inch wellhead running tool is run and landed on the nominal bore protector. The drill pipe is rotated to engage the dogs in the wellhead profile. A pressure test of the BOP stack and VX seal is performed at this time to ensure the integrity of the BOP stack connection. Pressure down the chain lines against the running tool. The testing tool is released by rotating the drill bit is then lowered and drilling for the 13 and 3/8 inch casing is performed surface. During the drilling phase of the Terra Nova project, optional casing strings of 11 and 3/4 inch or 10 and 3/4 inch will be installed. The 18 and 3/4 inch wellhead tool is run into the wellhead with its retrieval ring expanded. Nominal bore protector. The 18 and 3/4 inch wellhead running tool is then picked up.
It's just a rubber.
The bore protector is retrieved by picking straight up with the drill pipe. The 13 and 3/8 inch, 10 and 3/4 inch.
Sometimes these wear bushings and bore protectors, they may sit a little bit as you have gotten a little bit of cuttings or debris behind them. But normally this, call it, it's like an L-shaped rubber lip that just goes into the side, and that's all what keeps it in place, this bore protector. Yeah, but with a little bit of dirt behind, you may see impressive forces to release them.
11 and 3/4 quarter-inch casing
Yeah, everything that you see on the inside there would be the seal areas for all the different casings. If you have a vertical going scratch there, the whole wellhead is ruined. You won't get pressure integrity between the different casing strings. Good question. Yeah, bore protector is just very often those are thinner in their call it the wall thickness. That's just a general thing. Naming culture and between bore protector and bare bushing is a little bit dodgy.
A string of casing. The 18 3/4-inch single The casing is cemented in place by pumping down the drill pipe and up and around the casing hanger. The cement is then allowed to cure. The single trip tool is released by rotating the drill pipe to the right 4 turns. After completion of the 4th turn,
Yeah, so this goes a little bit fast. We see these ports here. They are the return ports. When you are pumping cement, you need returns, right? So they go there, and this orange part here would be the seal, the seal assembly. Typically on dry wellheads, these are installed by hand, just lowering them down after the running tool is off, right? Because you have full access to the wellhead. Whereas here, subsea, they are sitting on the running tool itself. You do the whole cement job, everything else, and then, as the lady is trying to say, before I interrupted her so rudely, you rotate to the right, and you, yeah, let's just see it. She's setting it now after the cement job is done.
will drop approximately 8 inches and will land the seal assembly. The seal assembly is the primary component providing sealing integrity to the The seal assembly is locked into position by closing the BOP and pressurizing the seal to 3,500 psi for the 13 3/8-inch size or to 4,500 psi for smaller casing sizes. The pressure forces the lock rings down over the casing hanger to the wellhead if the lock ring has been run. The primary sealing element of the assembly is the straight bore metal seal, or SBMS. Wellhead.
Yeah. So here is the lock profile in the wellhead itself, and here is the lock profile in the casing hanger, and it's supposedly metal to metal seal here. So if this area has a scratch, then basically you're in trouble. So good question earlier.
The same in all casing sizes. The seal assembly and BOP are tested by applying pressure down the choke or kill ring against the seal assembly.
Yeah. Basically, when you test the seal, if it leaks, you will have returns. So typically it's open. Let me see if I can remember these things. Yeah, you see it in the annulus below, right? So it's supposed to be a very small volume that you're testing instead of a large one. We always do that as engineers, knowing the different volumes that is required to test.
Single trip tool is retrieved by a straight upward click of the drill string. In preparation for the next drilling procedure, a wear bushing is made up to the spring-loaded tool. It is run and landed in the high-pressure wellhead. The spring-loaded tool closes with 3,000 to 5,000 pounds of downward weight. If the BOP stock requires further testing, it may be tested at any time. The spring-loaded tool is removed by picking straight up with the drill pipe. An overpull is required to shear the brass shear pins on the running tool and disengage the spring-loaded tool from the wear bushing. This will require approximately 12,000 to 18,000 pounds of overpull shear pins installed when running the bore protector. With the wear bushing.
Yeah, so typically this is something that the operator of the rig do for set up these wear bushings with the right shear pins, rubber seals, and so on, and fix it to the running tool. There are two tools they are mentioning here: the spring-loaded tool and the single-trip tool. These are old tools. I am not sure if they have renewed them, to be honest, but the mechanisms are very similar from one vendor to another provider of these services. As you see, the L seal sits here, and this whole the function of this blue wear bushing is basically just to protect the seal area for no other reason. Yeah, and notice, of course, that when you have installed a 13 to 8 inch casing hanger, then of course it becomes smaller. For every casing hanger that you run, you have a shorter one, so you have dedicated wear bushings and bore protectors for each service, basically.
In place, a hole is drilled for the next string of casing. In this case, 9 5/8 inch casing is used. Additional casing sizes may be run.
Yeah, so
Upon completion of drilling operation.
basically, this is a repetition. Every single casing hanger is just the same. It's a repetition of what has been done now. Pull the bore protector, run the next casing hanger, cement it, set the seal assembly, so on. What would be new here would be
The wear bushing. The 9 5/8
Christmas tree. Let me see if we retrieve the BOP stack. Basically, what you do then is to do a temporary P&A. You secure your well, make sure that you have enough barriers, and then you can release the BOP. You establish a secondary barrier before you release the BOP. That would be your secondary barrier. Now, let's see. You have a TA cap, which is basically just a debris cap so that dirt does not go into the well. And here comes the Christmas tree. You see how it looks here. Yeah. And that you have a running tool in top, basically more or less very similar to that of the template that they were showing earlier.
The tree is run on drill pipe. Guidelines are used to
Yeah.
the 18 3/4 inch tools for the integrity of the primary view.
Yeah. There is an umbilical run along the pipe connecting to the running tool, and when you see the running tool of the Christmas tree, it looks like a Christmas tree sitting on top of the Christmas tree. That's basically what it is, if you just calling it bluntly. You have a connector going from surface on a big drum, and there's a lot like a control unit on the rig to operate different functionalities. A lot of, call it hydraulic lines and electrical lines to operate the different functionalities that would be required just during the setting and later on during well testing, for example. And yeah, reading off gauges, reading off all these things. Yeah, controlling them. Yeah.
You do streams instead?
Yeah, I guess that those would be of the newer systems. You know what they're going on, what they're talking about now is to use signals, Wi-Fi type things instead, and going completely electrical, because hydraulic means um, slower. It means well, hydraulic would be in the category obsolete, I guess. And this again, this presentation is old. So it shows you the principles, and a lot would be the same, but like you're saying, systems would be newer. They're talking about the Vox control system here and so on. So that's old, I guess. Yeah, at least the hydraulic, fully hydraulic ones.
Seal, the adapter bushing external seal. The subsea tree assembly is connected to the manifold server via the stroke adapter. The ROV rear panel of the tree, which strokes the connector and piping cover to the connector's collet fingers are then extended to the manifold hub. The connection is
Yeah, I think that's enough. I think you have seen the principles of how these tools are run and utilized, and how the components work. The main components, they are like Lego. You can replace here and there. Just a curiosity. Interesting fact, Professor Sangesland here at the Institute, he's the one that designed the horizontal Christmas trees. And what would be the next here would be, of course, to run the completion, because it lands inside the Christmas tree, right? Whereas on a vertical, you run the completion and then you run the Christmas tree, right? So there's a difference between those. You guys know that. All right, I think we leave the subsea part of it, and we are going back to a purely tubular design. We will also have a discussion if and how much we should go into the detailed parts of the typical oddities of each section, which is the next part of this presentation. Otherwise, we will just jump directly over to the more specifics of casing design. Right, small break.